Alright, welcome to AP Video 15.7. This one is going to be on indicators. And this will wrap up our unit on acids, bases, buffers, and titrations. Main idea here is to understand what an acid-base indicator is, how they work, and how to choose the correct one while doing a titration. So indicators, or acid-base indicators specifically, are substances that will change color according to the pH of the solution. They themselves are often weak acids, and they're in the form of HA and A minus all the time. It's converting from one to the other. Okay, and each of these two portions of the indicator have their own unique color, which allows us to figure out pH based off of that. So a general reaction for an indicator looks like this. We use the abbreviation HIN, kind of like we said HA earlier. Rather than saying A, we use IN. And it dissociates into its two parts, which is H plus and IN minus. And the HIN has its own unique color, which we'll just call it color 1. And the IN minus, the conjugate base essentially here, has its own unique color. We'll call it color 2. And this essentially is equilibrium. So we're going to think Le Chatelier's principle. And essentially equilibrium is disturbed by the addition of H plus or OH minus. When you add acid, this is what you're increasing the concentration of in water. And when you add a base to solution, you're essentially increasing the concentration of hydroxide in water. So for example, when we add acid, we increase that H plus. It's going to shift equilibrium to the left. If you increase the amount of this, it's going to shift away to the left. And color 1 is going to be the more dominant color, and you should see that particular color when you're in acidic solutions. Okay, and in a second scenario, we'll look at the opposite, is when you add a base to solution. Essentially hydroxide from the base will react with the hydrogen ion here of your indicator, which will decrease it. And when you decrease this, Le Chatelier's principle states that you're going to shift towards it here, and it's going to shift to the right. And that will produce more of this substance, which gives the solution a second color instead. So indicators are nothing but equilibrium, shifting left, shifting right, depending on how you manipulate that H plus for the indicator there, and can produce color 1 or color 2. Now in practice, the indicator will change colors only over a small pH range for most indicators. So if we take a look at figure 15.8 from our textbook, it shows us where most things do their color change. And the way to kind of read this, and we'll look at bromocresol green first, just as an example. Bromocresol green, when it's below a pH 4, it's yellow. Okay, so although the color stops on this, it's basically, that means that's the last color that's going to be. So it's going to be yellow all the way through here. It does a small change of color, well, not small change of color, but a change of color in a small range. It goes from yellow to blue in about a range of, most things are about a pH of 2 over that range. And at the other end here, it becomes blue, and it's blue completely all the way through here. So this indicator changes color through this range here. Phenolphthalein, one we've done this year, is colorless, this region. So when it's below A, it's colorless, and it turns into a pink color in that neighborhood of like 8 to 9, and then it stays very bright pink as you go above that particular spot there. So indicators change color over a narrow pH range. Now what you want to do is you want to choose the right indicator, and the indicator you choose, you want it to be changing color at the equivalence point during your titration. Okay, so in reality, you have to know approximately what kind of titration you're doing so you can select the correct indicator. When the color changes, that's what we call the endpoint. So the endpoint is when an indicator changes color, and you want to try to match as close to the equivalence point as you possibly can. If not, they don't match very well and you've chosen the wrong indicator, and you'll have a hard time finding that equivalence point. So let's practice a little bit here. So here we have our equivalence point for a titration, and this looks like a weak acid titration titrated by a strong base. Here's your titrant, and you can tell because you started acidic, and it's got this little weird initial increase and then level off. That's one of the characteristics of a weak acid titration. Now the equivalence point here is the midpoint of the rapid increase region here, and it looks like we're at a pH of 9. So we want to pick an indicator that changes at a pH of 9 for color change. So when we look over here at this particular chart here, anything with a pH 9 would be a good indicator. So we're looking at phenol failing, and we're looking at this cresol failing. Okay, those would be good indicators to choose for this particular titration because they would change colors when the end point is reached. Remember, or the equivalence point is reached when the moles of the acid part is equal to the moles of the base part. Okay. Here's another titration for practice. Here the equivalence point is right about here, so a little over 5, between 5 and 6. So anything between 5 and 6 changing color would be good. So we're looking at indicators that are in that range here. So there's quite a few here. We have the methyl red, we have the, I can't read it because it's actually too small on my screen, but something black tea, bromocresol purple here. Alzirin would start to turn color near that range there, and that bromocresol green's kind of on the edge there. So there are special indicators you want to pick because they overlap with where the rapid changing of pH takes place. Okay, so this is the video on indicators and what they are and how to choose the right one. Alright, good job on this chapter, everybody.